We were discussing about the cut set matrix Q, that is what we were discussing, and before that I must know what a cut set is. So, in my last lecture this was the thing we discussed. Directed tree graph was given to me. I selected one tree. Tree elements are called twigs. There are 3 twigs which have been named as 1, 2 and 3. So, there will be 3 cut set equations. What are essentially those equations? These are KCL applied not to the nodes, but to the cut set. So, cut set 1, it is named as cut set 1 because only this twig is involved 1. So, you write down KCL at this. Similarly, this cut set is called cut set 2. It divides the network into 2 halves and apply KCL there, but make sure that only one cut set is present. So, this is fine, fundamental cut set. Then finally, this cut set and you get this relationship. Now, this relationship can be written in terms of a matrix. How? This one, from this to this in a matrix form, I can write it as a matrix. Who will participate in this matrices? All the element currents. So, there are 6 element currents 1, 2, 3, 4, 5, 6, that is there. So, this column vectors will be I 1, I 2, that is I 3, I 4, I 5 and I 6. And then I will write here this side cut set 1, cut set 2, that is KCL at cut set 1, KCL at cut set 2, KCL at cut set 3. You see 1, 4 and 6 are involved with all positive numbers. So, 1, 4 and 6, others will be just 0. Similarly, at cut set 2, 2, 4 and 6 are involved, all are positive. So, at cut set 2 it will be 2, 4, 6. So, 2, 4 and 6. And at cut set 3 it is 3 is present, I 5 is minus 1 and I 6 is present. And this matrix is called Q matrix, and this is equal to 3 zeros, 3 rows, 3 zeros, column vector. We have seen A matrix had got similar thing, A into IE, that was also KCL, but KCL at nodes. So, here it can be written as Q into IE is equal to 0. That is the thing, important thing. What is the dimension of Q? Dimension of Q will be this side, number of rows will be number of twigs into number of elements E. What is the dimension of IE? It is E by 1. So, that this will be T into 1, that is what exactly we got it, fine. And number of twigs is how much? If total number of elements is E, total number of nodes is N, this is the number of twigs, we have seen that. This is loop. So, number of twigs will be N minus 1. So, number of twigs is N minus 1, because number of elements in a tree is N minus 1. So, this is the equation, fundamental equation. Now, we are familiar with the what is called the nodal method and loop method, and because of those two methods that A and B matrices were defined and things like that. Now, the question is here, what is the implication of this Q matrix? How can I use it to solve a network? Now, in a network, look at this diagram. In this network, if you know all the loop currents, then you can know all the branch currents. You have solved the circuit. Similarly, if you know the node voltages V A 0, V B 0 and V C 0, you have almost solved the circuit, because if node voltages are known, then this branch current will be V A 0 minus V C 0 divided by impedance, whatever it is I can find out. Now, the question is, what about this Q matrix? So, that is why those two equations were always drawn, that is these equations. A into I equal to 0, A transpose node voltages in terms of element voltages. Similarly, for the loop equations, B into V is equal to 0, B transpose into I L equal to I E. Now, what happens in this particular case? That is what we want. What should I do further? The thing is, in a network, if you know the node voltages, you have almost solved the circuit. All the node voltages are known with respect to a reference node, fine. Similarly, I am now telling this, you listen carefully, in a network, if you know the tweak voltages, then also you know the voltages across all other elements. Hence, almost you have solved the circuit. What do I mean? Come to this network. Suppose I have solved these voltages plus minus E T 1, somehow I have solved. This is the tweak voltage 1, which happens to be equal to E 1 only, I mean V E T 1, which happens to be equal to V 1 only, that is there for this element, because this is a tweak. Similarly, this voltage plus minus consistent with the direction of the current, this polarity I am writing. This is what? This is voltage tweak voltage. Let me write it in this way, V T 1. So, that no doubt prevails. So, V 1 is V T 1, tweak voltage V T 1 is this. Similarly, this let me call V T 2, and then I will say that V T 2 is what? This voltage V T 2 is the voltage across this element V E 2, is it consistent with this polarity, which happens to be equal to minus V B 0, that is okay, node voltage I am not considering. So, this is the thing. Where is the third tweak? This one. So, this is the direction of the current, voltage across it is, I will say, V T 3, which happens to be equal to V E 3. These are the things very easily I can note down. Now, you see, suppose I say V T 1, V T 2 and V T 3 are known. Suppose V T 1, V T 2 and V T 3 are known. If they are known, then I can find out the voltage across all other elements. For example, you can see VE4 will be VT1 and VT2 will be involved. Apply KVL, get VE4. What about VE6? VE6 can be related with this voltage VT1, VT2 and VT3. Start from this point, try to reach this point, you get that is VAC. Or in other words, if you know VT1, VT2, VT3, you can find out the node voltages, and if you know node voltages, you know everything in whichever way you think. Therefore, here the target is, one is the KCL equation at the cut set, that is one thing. Another thing is relating the element voltage with the tweak voltages. That is, if I know the tweak voltages, how to obtain the all other element voltages. So, let us do that now. Okay. So, how to do it? So, this is one equation. Should I write it here? Better what I will do is this, I will copy this portion and write it down. Okay, so, this I have got, and then I told you this I will write it, this whole equations we have written it in the form of a Q matrix, Q into I E is equal to 0 from the last slide. Now, here I will now try to relate element voltages with tweak voltages. This is what we will be doing. Okay, let us write. So, for example, I will say that VE1 is equal to VT1. Is not? VE2 is equal to VT2. Then VE3 is equal to VT3, VE4, that is the voltage across this element, will be this tweak voltage plus this tweak voltage, is not VT1 and VT2 will be involved here. Now, what about this thing? This will be VT1 minus VT2, is not VT1, then this is opposite minus VT2 or minus VT1 plus VT2. From this to this I come, VE4 is this one, this is plus, this is minus, I want to get. So, it will be this will be plus, minus 2 plus, both will be plus. Got the point? So, VE4, so start from this point minus 2 plus, then minus 2 plus, this will be VE4. Then similarly, VE5 is the voltage across this element, and what is the polarity of this VE5 is this way. So, I will start with this that is minus VT2, is not. From this to this if you go minus VT2, if I make a mistake point out minus VT2 and then minus VT3, minus VT3 and finally VE6, that is this voltage. VE6 has been defined like this, plus minus, and polarities of these tweak voltages are known. Now, this VE6 I will reach from C this way, this voltage and these tweak voltages will give me VE6. So, I start here. So, it will be minus V, this is this tweak voltage is V5 now. No, so from VE6 I want to find out. So, I will go with VT1, no sorry, VT1. It will be VT in terms of tweak voltages, VT1, then also plus VT2 and plus VT3, plus VT3. This will be the thing. Therefore, this matrix, this element voltages can be expressed as, let me write in longhand, that is V1, V2, VE3, VE4, VE5 and VE6. Here who will participate in deciding these voltages? VT1, VT2 and VT3. This will be this matrix. And here also I write T1, T2, T3 for my own reference. So, VE1 is VT1. So, it is 1, 0, 0. VE2 is VT2, 1, 0, 0. VE3 is also VT3, 1, 0, 0. This will be the thing. What will be VE4? VT1 plus VT2. So, VT1 plus VT2, 0. What will be VE5? Is minus VT2 minus VT3, and finally, VE6 is 1, 2, 3 all are plus 1. This will be this matrix. Now, if you see the Q matrix, it was like this. Let me copy it and put it there, so that the Q matrix was this one. This was my Q matrix, just so Q matrix, if you see, if you take the transpose, this is the Q matrix. Okay. This is the Q matrix from the previous page. So, if you take Q transpose, that is this first row, if you see 1 0 0 1 0 1 0 0 1 1 1 0 0 this copy did not work. I will better write it there, forget about this. Let me move to first. It was here. I will just go and rather read that from the previous page. What was the Q matrix? Q matrix first row was 1 0 0 1 0, it was 1 actually, this I wrote wrongly, is not? So, correct that, it will be 1. So, 1 0 0 1 0 1, see 1 0 0 1 1. And second one is 0 1 0 1 0 1, second one is 0 1 0 1 1, এটা match করলো না. See this Q2 is 0 1 0, second row 0 1 0 1 0 1, it should be 0 1 0 0 1 1. So, here you note I just made one mistake in the mistake means I dropped one terms. For example, while writing down Cartset 2 KCL, there was also I5 involved and it should be minus I5. This I have incorporated, you take care of that. So, your Q matrix also this entry will get corrected a bit in the lecture 63 and in the previous lecture as well, which I have pointed out. So, this is the thing. Now, then you note that this matrix Q I E is equal to 0, it is fine, and this expression, that is this matrix, then will become Q transpose into V T tweak voltages. So, I will write Q transpose into V tweak is equal to 0. These are the two equations. So, it is almost like some loop equations solving, but here what is done? Which one? This is V E. So, you can see that this will be V E. So, inconsistent with other two equations also, there is some KCL equations, A into I E was 0 earlier, A into I E this was 0, incidence matrix into I E was 0, this was KCL at the node, and then we noted that A transpose into node voltages is equal to your element voltages. In the same line, if you apply KCL at the Cartset, Q I E is equal to 0 and Q transpose into V T, the tweak voltages. What is V T? V T is this column vector. That will give you the elemental voltages. I can always express that. So, you know the element voltage or element currents, you have solved the circuit. So, this is another way of solving the circuit, where we will try to find out the tweak voltages. Is that clear? So, this in short is what is the three important matrices A, B and Q. Although I have not told yet how really now, after knowing this, how really I will solve the circuit. That I will do later. First, let me now take some example, so that quickly we can write down the ABC, A, B and Q matrix. For example, I give you now for a change some graph of a network which is like this, suppose, so that you also practice this. And what you how to approach the problems to find out ABC matrices. Suppose this is a network whose graph is this, and the direction of the graph, it is my choice, I choose it, or if it is given, I will do accordingly. Arbitrarily chosen. How many nodes are there? I will write the nodes A, B, C, D, and I choose O to be the reference, suppose. Okay. So, total number of nodes is 5. I come to this. Total number of edges or elements are 4, 4, 8, is not? Because this is element, and I name them quite arbitrarily 1, 2, 3, 4, 5, 6 and 7. Where is 8 gone? 8. So, these are the 8 elements present. So, first is what is a matrix? Reduced order incidence matrix. I have to draw it. So, I have to write down KCL at 4 nodes. So, at node A, B, C, D. What will be the KCL? And here you write all the elements 1, 2, 3, 4, 5, 6, 7, 8. So, at node A, which elements participate to decide KCL? Only 1, 2, 3, and all are coming out. So, 1, 2, 3 are plus 1, plus 1, plus 1, others are 0. If I make a mistake, point out, this is the thing. At what is the KCL at node B? At node B, 6 is coming out away from the node. So, 6 is plus 1, and other two are involved are 3 and 7, and both of them should be negative, 3 and 7, others I will put 0. These are the KCL. At node C, this is the thing, 5 is coming out from the node. So, assign plus sign to 5, and 8 and 7, 5 and 7 is also coming out, good, 0, 6 is not there, 5, 7 and 8 is minus, 8 is minus 1, others are 0. This is A. Then finally, node D, this is the reference node. At node D, 4 and 8 are coming out from the node. So, assign plus sign there, 4 and 8, and 1 is coming in. So, minus 1, 0, 0, 0, 0, 0. So, this is a matrix over. Now, I want to find out the Q matrix of this. So, what I have to do? I have to, or let me go step by step. So, get the B matrix. So, to get the B matrix, I have to find out the fundamental loops, is not? Trees and loops concept should be. So, I take a graph. There are so many graphs possible. Take this graph, take this tree. Suppose I take the tree like this. 2, 6, 5 and 4. This is a tree, all nodes are there, no loop is formed. Okay. So, the loops are here L3, this loop is L7, link, this link will form a loop L7, this is 7, loop 3 I will not, anyway loop 7. This one is links 8, which happens to be loop 8, and this one is link 1, is not? This will be the thing, and here it is A, B, C, D and O. So, what is the B matrix? B matrix is the KVL equations, is not? B matrix is the KVL equations, where in the fundamental loops, how many fundamental loops will be there, as many links are there. So, here is the fundamental loop, here is the fundamental loop, 4 loops are there. So, B matrix, so this was from KCL consideration, B matrix has to be obtained and we know that V into the element voltages will give rise to 0. You recall B into V E is equal to 0, that was the starting point. So, there will be KVL equations, how many equations will be there? Loop 3. Incidentally, you see this loop 3 fundamental loop should contain only one link. So, this will be, I am so sorry, it will be, arrow will be like this. This is loop current IL3, this will be loop current IL7, 8 direction was already mentioned like this. So, this will be the loop current IL8 and this will be the loop current IL1. So, B matrix will be, that is the KVL equation in loop 3. Who participate in the KVL equation? All the element voltages, is not? That is 1, 2, 3, 4, 5, 6, oh sorry, here space is less, 5, then 6, 7, 8. Loop 3 KVL equation, this way I have to go. Now, the polarity of the voltage EL3 is the deciding factor, writing +1 -1. So, this voltage 3 is 1, 6 happens to be also 1, same direction, 6 happens to be 1, but 2 is -1. Similarly, the second L3 I have done, then suppose loop 1 L1, the order is not that important, but you must understand this is the thing. L1, it will be what in this loop? It will be this voltage. Here what are the things there? V1, V2, all the element voltages. So, L1 loop, it will be what? 1 plus 5. So, 1 under 5 and then -1 under 2. This are involved, all other will be 0. And then 3, 1, then L7, loop 7. In this loop, it will be E7, that is this element voltage, that should be assigned plus this way. So, 7 is 1, 6 is also in the same direction 1, and 5 is in the opposite direction -1, 0, 0 0 0 0, finally L 8. What will be L 8 in this loop? This is equal to E 8, that is plus 1, is not? This is the sign, 5 also plus 1. Who are the elements involved? Why 2 or 5? This is 4. Na? So, this is 1, this is 4, you just see. So, this is 5 is plus and 4 is minus 1, all are zeros. 4, 5, 6, 7, 8. This is the B matrix. In this something will loop 1. Loop 1 is what? It is equal to, that is 4, it will be 1, is not? Here there will be second row. So, it was what was written? 0. So, second row it will be 1. This one 5 is not present, 0. Other things are hopefully correct. So, this is B matrix I can form. Finally, about the Q matrix we will discuss for this same problem how to develop, and in the last next 2 lectures I will take up a real circuit problem and try to solve it. So, be familiar, you try to, your home task is write Q matrix. How to write Q matrix? You have to write down, I will give you hints to form cut set. At the cut set you have to write down these KCL equations. Cut cell in this case is very simple. Is it? These are the link, dotted line. So, cut set means you cut the network into 2 portions such that one tree is always present. So, one cut set will be like this. This cut set I will name it as cut set 2 because element 2 twig, this twig is only involved there. Similarly, this cut set I will say it is cut set 6, is not? All arrows you put there. Similarly, this will be cut set 5 and this side will be cut set 4. So, try to write down, put the arrows and try to write down that. Thank you.